All right. What we're going to be talking about in section 3, just so that you guys know, is we're going to be talking about now what a logarithm is. Okay? A logarithm is another type of operation in math that we use for quite a few things. Here's how it looks. Okay? When you have log, and here's how you read that. Log base b, y equals x. Okay? So you have the log base b, y equals x. Now, a couple things that I want to make sure that you guys are aware of. On your calculators, I think you guys found e for me yesterday. Can you find log for me? It's right next to it. That's on purpose. Okay, they're on purpose next to each other. Here's the thing that you don't know. Your calculators are set up for you in order to do base 10, which means that if there's a 10 in the B position, then your calculator can be used. If it's not base 10, it ain't going to happen. So just so that you guys understand that on your calculators, when it says log, it's not going to give you an option to put a number in there for the B. Okay? So your calculators are set up to be base 10 because that's how we count. When you think about what we do, we go by, in our decimal places, we talk about tens, hundreds, thousands, 10,000s, and so on. Those are all powers of 10. That's how your calculator is set up. Okay? You are going to have other bases. There are other bases in the world. Have you ever heard of or seen on TV an ADT home security commercial? Yeah. Once they type in the code, what happens to the house? For those of you who have seen it.
It goes a thing around it.
A thing goes around it, right? And specifically, that thing that goes around it's a grid that has a bunch of ones and zeros. Have you ever seen that? That's called binary. Okay, and binary is base 2. So the only numbers that are in there are ones and zeros. There are different bases for many different things. Way back in ancient Egypt, they used to use base 60 to count everything. So think about all the different things. Like when we go to, once we get to the tens place, then it's the hundreds place. They would go to 60, and then it would be their next decimal place. Okay? I'm not going to show you anything with bases other than this stuff, so I won't actually have you counting in different bases, but I will have you do logarithms in different bases. That's the only difference. Okay? So just so that you guys do know this, there are other bases other than base 10, but that's the one that we always use. Therefore, that's why your calculator is always set to base 10. Okay? But there is a way around it. This is the same thing as me putting it as b to the x equals y. When I say b to the x equals y, I am now an exponential. Okay? Why am I an exponential? Because where is the x? I have an exponent now, don't I? Yes. Okay? And more specifically, it's the x, it's the exponent. The variable is in the exponent. Okay? So log base by equals x is the same thing as b to the x equals y. That process we're going to use in order to help us solve our problems. All right? This is how we're going to solve our problems today, is using this thing. So, first thing that they're going to have you do is they're going to give you something like this. It says log base 2 16 equals 4. And what they want you to do is just to get you some practice, at least for the first ones, and I want you to write that as an exponential, meaning exponent stuff. So, what number is in the base position? 2. Good. What number is in the exponent position? 4 equals how much? 16. Awesome. Nice job. Very good. That's your answer. Okay? You're not trying to solve anything on this one. You're just trying to rewrite it. We're not trying to figure out how much this is. A lot of people I've had go on further and go, well, 16 equals 16. Yes, it does. Good job. But you don't need to do 2 to the 4th right now. The only part it asked you to do was rewrite it as an exponential. That's all it wants you to do for the first part. Okay? Log base 4, 1 equals 0. Okay, I want you to try this one on your own. Once you get it in exponential form, share with your groups. See what you guys got.
Doesn't anything to the 0 power equals 1?
Okay, so group 3. So 1, 2, 3. Lauren and Faith. What'd you guys have? 4 to the 0 power equals 1. What do you guys think?
Yeah.
For the other groups, is that what you guys said too? That's exactly correct. And then if you think about it, when we talked about this, how many times have I told you in the last few days? Anything to the 0 power is always 1. So that's true, right? I mean, but that's not even what we were looking at. We were just looking at rewriting it as an exponential. Nice job. Okay?
This is so easy.
Good. I'm glad you think it's easy. I do too. Okay, once you get it, make sure you share with your group and see what you guys got.
How did you do it? 12.
12 equals 1.
Yeah.
Okay, so group number 8, which is right over here. Miss Madison, what'd you guys talk about? Don't know? You guys didn't talk at all to each other?
Well,
So what'd you guys get? 12 to the 1 equals 12? Is that what you guys got too?
No.
Yes.
Okay, again, this is the base down here. This one's the exponent. And this is what it would be equal to. Okay, so if you want to think of it that way, or if you even want to write that on your own notes part, you're more than welcome to. Base is the bottom number. Exponent's on the right side. Left side is what it's equal to. Are you guys comfortable with that? Are you guys okay with those?
Yep.
Good. That's a third of your assignment today is just doing that. So if you're comfortable with that, so am I. Then, the next piece is going to say 5 squared equals 25. Well, no duh. We know that. Okay? But what I want you to do for this one is, now I have it in exponential form. I want you to tell me what it would look like in log form. So I'll help you out with the first one. So first thing I'm going to do is I'm going to write the word log. What's the base number? Which one has the exponent? 5. Good. Then what comes? The 25, because the 25 is the lone one on the other side, equals the exponent, which is how big? 2. Awesome. Okay? All right, now you do. 10 to the negative 1 equals 0.1.
Wait. What?
Once you get done, share with your groups.
Oh. It's log 10. Point equals negative 1.
No, I start here, right? I start with you guys have 1, right?
Yes.
All right, somebody from the back group, like Ashley, Alexis, Bailey, and Arnatti. What'd you guys have? Log. Hold on, let me. log 10 in the bottom part. Okay, good. 0.1. -1. How'd we do, groups? Is that what you guys got too?
Yeah.
Awesome. Okay, good job. Do you need me to do any more of those? No. Awesome. Okay. So, second part to it is you're going to rewrite those as log form. Not too shabby? Okay. Now, this is probably the part that you're going to have to do the most work on today, which it's not even that bad. It's going to say log 464, and it's going to ask you to evaluate, which means I need to know what should be on the right side. Notice how there's no equal sign, correct? Do you see that there's no equal sign?
Yeah.
I need to know what this equals. So notice one thing, and don't use your calculators because guess what? Is this base 10? No. You can't stick it in your calculator. I've had people try to do this, like they type log and then they go 4 and then they go 64. Well, that's really just telling you log base 10, 4 times 64, and it's not going to give you the right answer. The real answer is really small. The answer is 3. Okay, here's how I do it though. What I'm going to do is I'm going to set it equal to x because that's what I need to equal, correct? That's what I'm trying to figure out. When I'm asking you to simplify or evaluate, I want to know the answer. Now, to deal with this, when it's in log form, I think it's more complicated than it would be to be in exponential form. So I want you to rewrite this as an exponential. What's the base number? 4. Raised to what power? X equals 64. Now, one of the things that you'll notice on this for you today, for today's stuff, do you notice how it says 4 to the x equals 64? Mm-hmm. They should and can be rewritten in order to be the same bases. Okay? Every single one of the problems that you guys are going to have today, you can rewrite them as the same bases. So what I'm saying is, 64 can be rewritten as 4 to the what?
16. No.
4 times 4 times 4 times 4. 16 times would be way bigger than 64. So, if you think about it, 4 times 4 is how much?
16.
16 times 4 is 64. So that's what I know you're getting at. How many 4s did I use to make that? Good. So 4 to the x equals 4 to the third. And you guys, if the bases are the same, then the exponent should be the same. And vice versa. If the exponents are the same, then so should the bases. So how big is x?
3.
If these are the same, then these are the same. So x equals 3. Every single one of the problems that you're going to have to do today, you will be able to rewrite it as the same bases. And then you just compare the exponents. Okay, so, looking at that problem, first thing I'm going to do is I'm going to set it equal to x. And now what? Yeah, put it in an exponential, which is what? Equals 256. So now, everybody, 4 times 4 is how much?
16.
16 times 4
64.
times 4.
256.
So how many 4s did I use?
4.
4. So 4 is the base for this one, and 4 is the base for that one. If the bases are the same, and the exponents are the same, so how big is x?
4.
4. Good. What do you guys think? Not too bad? Okay, now I'm going to throw a little bit of a wrinkle at you, but it's still the same stuff. No groaning. that says log base 5, 0.2. Okay, so again, same directions. You're going to set it equal to x. Now rewrite it. What would I have? 5 to the x equals 0.2. Now, we have a problem. What's it? Would it be a decimal? Well, maybe you might be onto something in a little bit. Maybe when I could talk about this through, maybe what you were going to say would be okay. So for this particular thing, do you notice how there's a 5 in the base and there's a 0.5 on the other side? Are those the same?
No.
No. But I just got done telling you that you should be able to make them the same, did I not? I'm not lying to you. It's just because the 0.2 is not set up the way you want it to be. As a decimal, it's 0.2, but as a fraction, what's 0.2? How do I convert 0.2 into a fraction? If it's 0.2, it's to the tenths place. So that's 2 over 10, which reduces down to what? 1/5. So right now, you have 5 to the x equals 1/5. 0.2 can be rewritten as 1/5. Now, are they on the same level? And what I mean by level is, notice how this is on, like, if I put this over 1, this is on the top of the fraction, and this is on the bottom. Are they on the same level? No. If I bring the 5 upstairs, what does it do to my exponent? I forgot. Mr. Berg's bringing them.
All right. We'll forgive you this time. I think I did it once.
Okay. So this 5 is going to come up here, and what's it do to the exponent on the 5? If it was positive now and you bring it up, it's going to make it negative. So that's 5 to the negative 1. Now are the bases the same? Yes. Bless you. So what's x? Negative 1. Questions?
Can we just do that? Yeah.
Can you do what, Michelle?
Try a bunch of them and see if it works.
Try it, but how?
Because
I did negative, I did negative 1 right away and I got.
Okay, so you just tried stuff on your calculator to see if it works? Okay, maybe. Will it work every time? I don't know. I know it will by hand. Bless you. I'll try another one like that. 1/5, 125. Again, all these are the same directions. So like the last 3 we've done, this is the 4th one we've done like this. It's all the same directions. Okay? So set it equal to x. What's the base? Raised to the equals 125. Now, I don't like fractions any more than you do. But don't tell anybody, even though I'm recording this and it's going out to everybody on YouTube. So, but I don't like fractions any more than you guys do. All right? So for me, on the left-hand side, I'm going to convert that not to a fraction. So when I bring the 5 upstairs, what does that do to my exponent? Makes it negative. So really I have 5 to the negative x equals 125. So, right, 125, so 5 times 5 is how much?
25.
25. And 25 times 5? 125. So how many 5s did I have to use? 3. So I have right now 5 to the negative x equals 5 to the 3rd. Are the bases the same? Yes. Then the exponents need to be the same. Now in this particular problem set, we have negative x equals 3. So does x equal 3? No. If I divide by negative 1, I get x equals what? Negative 3. 3 divided by a negative 1 is negative 3. Okay? And the last one I want to do with you, it's the same process. The only difference is we got to change the bases again. If I have log base 36 and 6 here, again, I'm going to do the same thing. Set it equal to x. Rewrite it as an exponential. 36 to the x equals 6. Now remember what I told you today. I wasn't lying to you. Today, you can rewrite those as the same base. That's what I said. I didn't necessarily specify that the right-hand side could be written as the left-hand side. I just said that they can be written as the same base. Right? Hold on. So, here's my point. I can't make this 6 go up to a 36. But I can make the 36 come down to the 6. So 36 is really 6 to the what? Squared. What 6 to the what power gives me 36? Right. So this is going to be rewritten as 6 squared. And then don't forget you still add to the x. Natty, what's 2 times x? Good. Thanks, Nat. Are the bases now the same? Yes, they are. Can you help me out with one thing, because I forgot? What's the exponent on the one on the right? If there isn't one written there, it's understood to be a 1. If it helps you, you might want to write that. Okay, if you didn't forget. A lot of people screw that up because they put it as a 0 rather than a 1. Okay? Are the bases the same?
Yeah.
So then what do you do with the exponents? You set them equal to each other and solve for x if need be. So what do you have to do to get x by itself?
Divide by 2.
And what's 1 divided by 2?
1/2.
1/2. So x equals 1/2. You might have 1 or 2 of those, but it's probably only going to be like one of those, like that. Okay? Now, again, like I mentioned to you guys, the majority of your assignment today is going to be nothing more than rewriting. When you look on page 314, 5 through 10 says rewrite the equation in exponential form. So you just have to rewrite it and that's it. 11 through 16 says rewrite in log form. So again, you're just rewriting. For those 2 parts, you're just going to rewrite. That's all you're going to do. And then 17 to 24, evaluate, which is what we were just doing the last like 5-6 problems dealing with. Okay? So on page 314, 5 through 23 odds.